in this lesson we're going to try and change hours and minutes into decimal times. We have done that before, but we're going to do it with different minutes instead of just 30, 15 and 45. And then eventually we'll try and use this in calculations, because once we get our minutes into a decimal we can use it in a calculator. So the first thing to do here is to try and think about what you divide 30 minutes by to get 0.5 hours, because we know 30 minutes is half an hour. We know half an hour is 0.5. We've done that already, we did it in the previous lessons. We should know already that 15 minutes is a quarter of an hour, which is 0.25. And also 45 minutes is 3/4 of an hour, which is 0.75. But what number can you divide all of these by to get these answers? Because then if we can work that out, we should be able to apply it to something like 10 minutes or 6 minutes or so on. So hopefully you've had to think about that and you've come up with this idea of 60, because 30 out of 60 is a half. 15 out of 60 is a quarter, which is 0.25. And 45 out of 60 is 0.75. So you can check these in the calculator. If you do 45 divided by 60, pops out. Right, so this is what this allows us to do is harder calculations. So if we're doing 36 minutes and we want it in decimal hours, if you like, well, it's more than a half, isn't it? 30 was a half, so it's going to be higher than 0.5. If you do 36 divided by 60 in your calculator, there you go, 0.6. Then you can use that in your calculations. Second one, 9 divided by 60. You can try it. 9 divided by 60, 0.15. And finally, 3 divided by 60, 0.05. So not too hard, just remembering to divide the minutes by 60, because there's 60 minutes in an hour. Right, what if you had a kind of slightly harder one here? Change 2 hours and 21 minutes into a decimal. So hopefully we can realise that's 2 point something. It's 2 and a bit. So we just have to sort out the 21 minutes part of it. So we'll just do what we did up here. 21 divided by 60. Well, that's 0.35. You do that in your calculator. So what that means is that's 2.35, and then you're ready to use that answer in calculations. Okay, last one here, 3 hours and 6 minutes, so we should know that's 3 point something. Sort your 6 minutes out, 6 minutes divided by 60, that's 0.1, and then your answer should be 3.1 hours. So when you're doing these kind of calculations in the book, I would make sure you write it out like this, okay? Just divide your minutes by 60 and write your final answer underneath. Okay, finally we'll look at some calculations, but before we do that, if you think about this, how do you calculate the distance to the moon? How did they do that? An interesting question, which might you think, well, how? I don't know. Well, what they did when they landed on the moon, there was previous estimates of that before, but what they did when they landed on the moon, they put reflective mirrors in the moon, so that what they could do is they could fire a laser beam at the moon, like this. So they fire the laser beam at the moon, and the laser beam reflects off the lasers on the moon, the reflective pieces on the moon, and bounces back. Now what they can do here is they can use this information to work out how far away the moon is, because they know that the laser travels at the speed of light. They know what the speed of light is. So you've got the time, you can time the time it takes, and you've got the speed of the light, and you can work it out using your normal speed distance time triangle. So here's how we can think. When astronauts landed on the moon during the Apollo program, left smaller reflective mirrors on the surface. Astronomers point lasers at the moon, which travel all the way to the moon and then bounce off and return back to the Earth. They time this process, and they use the speed of light, and they can work out the distance to the moon. Okay, right, let's look at a couple of questions, one involving the moon actually. Right, so the first question, calculate the distance a ship travels at 38 kilometers per hour for 18 minutes. So distance, right, okay, so distance, that is speed times time. Now, before I do that, I can't put 18 minutes into my calculator because it's kilometers per hour. So I've got to change that into hours. So 18 divided by 60, 0.3. Go with your formula. Distance is speed times time. I've got my speed of 38. I know my time's now 0.3 instead of 18, which is a common error. Use your calculator. There's your distance, 11.4 kilometers. Okay, final one. Calculate the approximate distance to the moon. Okay, the speed of light. This is the speed of light. You can look it up. It's 300,000 kilometers per second, which is a ridiculous amount. 300,000 kilometers per second. Let that sink in. The time it takes is 1.28 milliseconds, or 1 second and 28 milliseconds, and you can then work out the distance. The same formula. Distance is speed times time. So you take your speed and you times it by your time, and it pretty much works out roughly at 351,000 kilometers. And if you look it up, the real distance is actually quite close to that, 384,400. These are just estimates. Certainly the speed of light not, but the time is. Okay, you should be able to try some of those calculations yourself now. Remember to change, if you get something like this where the time's in minutes, make sure you change it into decimal hours by dividing by 60.